Okay, seems you're live. Hi, hello, good morning, good evening, good afternoon to everyone from whichever part of the world you're joining from. I'm Mudit and I'm from DeFi. With me, I have Supreet, who's from Databuzz. How are you all doing? If you're watching me live, watching us live or later, we hope you're doing great. Hi, Supreet. Good to see you again on DeFi with this live session that we do together.
Yeah, I think it's great. And now I've lost the count of the number of sessions we have done in collaboration, but I'm super excited about that. Uh,
Yeah.
so,
So I guess the community might already know a lot about you and Databuzz, but if you could introduce it briefly for the new set of viewers, it will be really great.
yes, I will. So Databuzz is a volunteer-driven community similar to DeFi. Our goal is to help people who want to pivot in the field of tech, AI, MLOps, data science, and we help you grow with sharing the resources. Some of the resources are in the form of articles, and some are in the form of these sessions, and others are in the form of fireside chat series where we invite people to share their unique journeys on how they pivoted into tech or they did something breakthrough. So I'm really excited to be here. And today we have a very unique, I would say we are discussing a very unique topic, AI for natural disaster management. And before meeting our speaker, who is Deepali, and she's an ML engineer at Alpha Square, I didn't think that this could be a thing where we'll be talking about AI for natural disaster management. So I think I am very excited to learn, and I hope all of you are as well. So, Mudit, can we invite Dipali and let her introduce herself and her specializations?
Yeah, sure. I think that sounds good. I would just do a brief intro of DeFi for those who are new
Yes.
to the sessions. So DeFi, as Supreet mentioned, is a community. It's a global community of AI enthusiasts from 150 plus countries. You can log on to DeFi, you can learn AI for free, and we're basically working towards the vision of educating and building AI for all. Every Saturday at the exact same time, we host an AI leader who's very kind enough to come and prepare and then take these sessions. Databus is one of our old partners, so this is where this is where you get to ask any questions that you might have to the speaker, and we'll take them up. So the comment section that you have in front of you on whichever platform you're joining from is super helpful because that is where you put your questions. So let's dive right into it. This topic is AI in AI for natural disaster management, as Supreet mentioned, and I'll quickly loop in Dipali also. Yep. Hi Dipali, how are you?
Yeah, I'm good. Thank you, Mudit, and thank you, Subrit.
Yes, of
Thanks for
course.
yeah. I think we can probably dive straight into the session because people are excited to learn from you. I see a hi from Siddharth. So hi Siddharth. Let's Dipali, the stage is all yours. We'll probably head over to the background and you can take the lead.
Thank you, thank you. Hello, everyone. Yeah, and can you share the screen, Mudit? I think I cannot see the screen.
Yeah, just a second. I'm just sharing. 1 second.
Yeah,
Okay. So the sharing window option doesn't seem to be working very seamlessly, but yeah. Okay, I'll share this tab instead. Yes. 1 second. Just give me a moment.
mhm.
By the way, I see comments from Sujit, Vaibhavi, Andres. They say hi Dipali. So yeah.
Hello, everyone. Hello.
Okay, just a second. Okay. Yes. Fair enough. I think it should be visible now.
Yes, yeah, yeah,
Great. Yes. I'll go to the background.
yeah. I can see it. Um, Thank you so much. Thank you, everyone, for joining in today. So the today's topic, as Mudit and Suprit mentioned, it's AI for natural disaster management. As we all know that climate change is a most serious threat that we are facing today. And Modi, can you go to the next slide? And as the climate changes, it makes our planet hotter and more drier. And you see all those natural disasters like floods, droughts, wildfire, tornadoes, and hurricanes. They are becoming new normal now. And you must have heard about all those increasing number of forest wildfire incidences in recent years from California to Australia and to India. They are the most visible and catastrophic indicators of our warming planet. And we are also losing, the Earth's great carbon sinks, which consumes around 110 billion metric tons of carbon dioxide. And as you all know that in recently we experienced this heat wave episodes in many parts of the world, and they are again warning us, to take action against the climate change before it's too late. And having said that, now it's very important for us to mitigate the climate and the climate related issues. And also this the climate change has increased the frequency and the magnitude of these natural disasters, and now it's a time to address those issues at global, regional, and even the local level. And we believe that the AI has a potential to solve those climate related problems. Actually, in fact, the artificial intelligence is a most powerful tool that humanity has at its disposal in 21st century. So I will go through some of the case studies where I used machine learning and deep learning models to predict the floods, desertification, rainfall, and land cover. Use land cover. Can you go to the next slide, please? Yes, thank you. So, this is a study carried out in a small country in Africa. It's called Togo, and this is done in collaboration with the Omdena. I'm not sure how many of you are aware about the Omdena, but I will talk about it if you're not aware about it in a bit, or maybe in the last. This country, Togo, is highly vulnerable to natural calamities. So the floods and droughts, they are very common in the country, which in turn has the negative consequences for its inhabitants and also on the environment and the economy as a whole. So, monitoring, and predicting the flood risk, it's very critical in order to, have this appropriate flood and environmental management solutions. So, what we did is we used this model called analytical hierarchy process, which the identifies and map the areas of high flood risk. There it's HP is basically a multi-criteria decision making system, which takes into account various factors. You can call it a criteria, and we integrated these various factors in this study. For example, you can see here below the density, slope, type of soil, the population density. All these factors, they contribute to the floods. For example, slope. So the danger from the flood increases as the slope increases. Even the type of soil and the texture are very important because it determines the infiltration of the water and even the water holding capacity of an area. Um, so what we did, we prepared this hazard map and vulnerability map. Can you go to the next slide? So as you can see, this is the AHP model. So it's, this study we divided into three parts: data collection, data pre-processing, and building this AHP model. So as a part of, go to the next slide, please. So as a part of data collection, we downloaded this country's boundary shapefile. So it's it's the shapefile. Um, I have no idea. I mean, if the audiences are aware about the shapefile format or not, but uh, this is, it simply gives you the boundary of the country, and then what is called the digital elevation model, which we generated using this advanced land observing satellite, which is called the ALOS pulsar, and also the land use land cover, which is generated from Copernicus global land use cover website. So this is some other part of the data collection. And can you go to the next slide? Thank you. So just generating this data is not enough, because we cannot use this data as it is. So we needed some pre-processing. So we use this platform called QGIS, which is called a Quantum Geographic Information System. It is open source software platform that allows users to create, edit, visualize, and analyze geographic information, uh, or the geographic data. So after generating these layers that we collected, I showed you in the previous slide. So we created the slope map, and as I said, like those factors like slope, precipitation, population density, they contribute to the flood. So we used that data and generated the different layers. And uh, why we needed actually those layers? Because we did not have the label data, and for the machine learning, the deep learning models, we need to have the data. So we created this slope map using the digital elevation model, and also this Euclidean distance and the drainage density. Because when we are talking about the floods, the drainage density or the drainage network, it plays a very important role. Because if there is no proper drainage facility, so might be a possibility of flood. So we created all these maps and put it together using the HP model. Next slide. And in HP model, so we what we did, we assigned weights to each of the layers, or we can call it a parameter, according to their contribution in the flood prediction. For example, the precipitation, it plays a very significant role. So the precipitation has been given more weight while creating this hazard map. And even the land use land cover, it has been given more weight while creating this vulnerability map. So we put all these layers together using something called weighted overlay analysis. And as I said, we use for all this processing, we use this QGIS, Quantum Geographic Information System platform. And we put those layers together and created the map. Can you go to the next slide? Yeah, here you can see the a flood map and hazardous map, and you can see how we use all the factors. and interpolated those layers and integrate those layers and created the maps. Next slide. Yes. So after creating those flood maps, once we have these flood maps, then we generated the training and testing data sets using stratified sampling to build the machine learning model. Can you go to the next slide? Yeah, here you can see we use this six machine learning models, and we use ROC as a evaluation metric, and you can see that this the ensemble model which perform best as the curve is very close to the top left, so that's the best model we got here. Yeah. Next slide. Yeah, here you can see the comparison between the HP model and the machine learning model. Actually, we could have used this HP model as such to predict the flood, and you can see the areas in red which are highly vulnerable to floods. But we went one step ahead and built this machine learning model on top of this AHP model, and you can clearly see here how the highly flood prone areas here in the red, and the less flood prone areas in green. Yeah, next slide. Yeah, so this was another project that I worked on, and this was in collaboration with Fruit Punch, and the goal of this project was to build a model that can detect the excess water in the forest from the satellite data. So this, the satellite data, using the satellite data, it's very useful. So sometimes when we lack the water, which destroys the forest, but even the too much water can kill them. So when the trees that are not adapted to flooding, and they're underwater for extended period of time, their roots weakens and they die. So water logging, that's called the water logging. It's one of the main reason of forest deforest destruction in Latvia. This is one of the European countries, and for this we use this Sentinel one SAR, or some called synthetic aperture radar data. And for this, we use the platform called Google Earth Engine. It's again a platform where you can you can actually use the data. You don't have to download any data because they have an inbuilt catalog of petabytes of data. So you don't need to download the data, because sometimes these satellite images becomes very heavy, very computation heavy. This GE platform is a wonderful platform where you can use the data, you can process the data, you can visualize the data, and you can build the map, something like the map you can see on the screen here. And you can clearly see this red areas which are flood inundated. So this is very useful platform. Next slide. Yeah, the another challenge of the project we use I worked on was the desertification detection. Again, we use this satellite images here, and build a machine learning model using this satellite data. Okay, next slide, please. So, as you all know, that desertification is a major environmental challenge that we are facing, and even the country. This is done in Iraq. So this desertification not only causes the problem to the ecosystem, but it leads to many other problems, ranging from affecting the agricultural sector, and then it again leads to the more hunger problems, even the displacement of the people. So, and the rate of this desertification has increased by 39% in the country. So, we decided to uh, work on this desertification challenge problem using the machine learning and AI. And next slide. So, what we did here was we used something called the vegetation indices. So those vegetation indices gives you the idea, what is the vegetation cover in the country and how it has been changing over a period of time. So the first index which we used is called NDVI, so normalized difference vegetation index. um, so basically those the satellite images has more than three channels, unlike our regular PNG or JPEG files, or the images that the photos that we take from the camera. It has some extra channels, for example, near infrared channel or shortwave infrared channels. So these are not visible to human eyes, but they can, using the satellite data, we can use those channels and capture the bands in electromagnetic spectrum, um, uh, in the electromagnetic spectrum. So yeah, another index we use were the normalized difference built-up index. So it gives you the idea about the built-up areas, so and how it has been changing. Next slide. Okay, so here you can see, and this vegetation um, index, normalized difference vegetation index, is ranges from -1 to 1. And as you can see here, the index, the values more towards 1, the positive values that signifies um, the healthy vegetation, and the values towards the negative side. Negative is actually indication of the water bodies, but towards 0 and from this range, that signifies that there is not a very healthy vegetation cover. Next slide. Okay, so what we did was we carried out this time series analysis. So for that we use this Moody's data. Uh, I'm not sure if you know about the Moody's, but it is, a satellite-based sensor which is used for Earth and climate observations and climate measurements. So it's called a moderate resolution imaging spectroradiometer. So we collected this data, Moody's data, and again we use this very useful platform called Google Earth Engine. And this the Moody's data, it has like revisit period of 16 days. What does that mean? So every 16 days the satellite captures the data, and then you can use that data. And as I said before, this GEE or Google Earth Engine platform is very useful. You can just use the data there, and then you can pre-process the data. So that's what we did. We got this Moody's data, and then um, we use this data uh, in machine learning models. And sometimes what happens is, when you have those satellite images, and when there is a cloud cover, you may not be able to capture the clear images. So using this platform called Google Earth Engine, you can remove the cloud cover, and if there are some heavy aerosols or the cloud mask, you can remove that. So it has that function as well. So it's very handy and very useful. Next slide. Okay, here you can see all this NDVI series that we created, time series, and these are for the two regions in Iraq. Um, uh, and then you can see the prediction, the forecast in orange color. Yeah, next one. Okay, so this is a GIF file that I created, where you can see the changes in the vegetation cover over a period of time. Next slide, please. Okay, so another project that we worked on was a land use, land cover classification. So this is again in this, we again use the Google Earth engine as a platform, where we collected the data. And first, actually, you need to select the area of interest. Of course, we are carrying out this analysis in, we did this in Iraq. So we selected the area of interest, then we collected the data, use all this satellite data, and then calculated all those indices. As I said, they can be the good indication of how the land use or land cover has been changing, how the vegetation has been changing, how is the built up area. So all these factors contribute to the land use, land cover classification. And once we have those data, then we collected the training samples, and this again can be done, everything can be done in Google Earth Engine. And once we have the data, we ran the random forest model on it. Yeah, next slide, please. And here you can clearly see here the land use, land cover classification in the central part of the Iraq. Next one. Yeah, and this is animation where you can see how the green cover has been changing over a period of time. Next one. Yeah, and here you can see this area is a barren land, and how it's been changing over a period of time. This is the GIF animation here. Next one. Yeah. So the next project is rainfall prediction using the machine learning. Next one. Okay, so here we use the balloon data to build the model. So these weather balloons, they are very useful for atmospheric scientists and for the farmers and the local communities as well. So they can give you the information on, the temperature, humidity, and the pressure levels. So these balloons, they are called as radio sonde balloons, and they capture all the data when they fly in the atmosphere at different pressure levels. Next one. So all this data which is collected by this balloons, uh, uh, it was in the CSV file format. And then we also use this historical data. When we are building the machine learning model, you need some historical data as well. So we use this historical data from global hourly integrated surface database, 10 years of data we used. And then this data, because when the balloon fly in the atmosphere, it may not capture the data at various pressure levels because of some reasons. So there were a lot of missing values in the data set. So we use this KNN imputer to fill up the impute missing values. And then there were a lot of again the outliers also. So we experimented with this interquartile range function for detecting the outliers. Then after we have this data, we did perform this exploratory data analysis. And before jumping into the machine learning model, this is a very important step where which tells you which features are good and which features you can ignore, and what are the correlations between all those features. So we did this exploratory data analysis as well. And also we needed to do some data pre-processing steps, for example the normalization, because when when these balloons captures the data at various pressure levels, the pressure level is not constant, right? So it gives you the reading at a different scale. So we needed to normalize this data, and we did use the min max or the standard scalar for this. And also there was a lot of skewness in the data. That means it was and we needed to remove that using and we use this log transformation function. Next one, please. Okay, and once the data is ready, it's been processed. And so we use those machine learning and deep learning models, and uh, um, we built this tree-based models called XGBoost, CatBoost, and Light GBM, and also we tried convolutional neural network models as well. But on this kind of data, we found out that the XGBoost model performed the best, and we got an accuracy of around 85%. Next one. Okay, yeah. So this was another project where we monitor the reforestation using machine learning. So this was again done in collaboration with the Omdena. Next one. Yeah, so this is a pipeline. This is a general pipeline, and where you can see we collected the data from um, satellites, and we also the partner also supplied the drone data, and we also downloaded this meteorological data, because all this again the factors um, like the temperature, pressure, humidity, they contribute to the reforestation success. So we collected that data, and then we pre-processed the data. Again, those satellite images, the open source satellite images, they were uh, not very high resolution. So we needed to do some um, mm, pre-processing as well as the super resolution of the images. So I'll talk about it in a bit later. And then we use all these indices again, uh, and then we build the time series models using this meteorological data, and then we built this unit model. Next slide, please. So here you can see this the mostly for all these projects we mostly use the satellite data, But satellite data, as it's we use this open source satellite data, but sometimes resolution might not be that good. So we had to use this super resolution of the images. And the partner also, as I said, supplied with the drone data or drone images, and these images are mostly in a TIFF file format. Yeah, next one. Okay. So now that coming to the data pre-processing and analysis. So as such, as I said, like you could probably use those TIFF files, but you need to extract the metadata because it contains a lot of information. Mm, for example, the height and when it's the time when it is collected. So it gives you all this useful information. So we extracted that metadata using the EXIF files, and then we needed to geo-reference those images. And here again we use the platform called Open Drone Map. This is a API you can use for processing the drone images. And then we extracted the ground sampling distance, because that's what we used for building the unit model. So I'll talk in a bit about this. And then, as I said, for those satellite images are were not in the good resolution. So we did use this super resolution model, so like SRCNN, which is a deep learning algorithm. And then the model, we built the model, and the model was built using this transfer learning. Um, yeah, can you go to the next slide? So as you can see here, the image before super resolution and after super resolution. This work, but this in this image you may not be see much difference, because um, the trees, the saplings were very small, and they were just hardly planted there. So even even after doing the super resolution, you can't see the much difference. But this is a very useful algorithm that can be used as a as the trees grows. Next one. Yeah, and here you can see the time series models that we built using the parameters, meteorological parameters like temperature, precipitation, and you can see the forecast here. Next one. Yeah, and as I said, we built this unit model, which is a deep learning architecture, and we use the transfer learning. So we use this efficient net as a backbone, and then for evaluating the matrix. For evaluating the model, we use the matrix called IOU, precision and recall and loss. So these, the model just gave us the mask, right? Whether there is a vegetation or no vegetation. So we had to do some calculation to find the vegetation percentage, and we use this calculation here. So we definitely needed some, the post processing. Next slide. Yeah, and then we took that time series model, all the vegetation indices, and we integrated into the dashboard using the Streamlit. So we built this Streamlit app, and here you can see the number of the trees. It's the approximation. The model can't count the exact number of trees, because as I said, that was a main challenge, because the saplings were very small. Even we have this high resolution images, but detecting those small saplings for the satellite images can be very challenging. But still, the model can give you the prediction. I mean the approximate number of trees. And here you can see the vegetation indices, how we use that. So it will give you tell you about the vegetation cover. Next one. Yeah, I think that's pretty much it. And if you want to know more about those projects that I worked on, there is a link to these articles, and you can contact me. This is my email and LinkedIn profile. Thank you. So if anyone has any questions, I don't think I can see the question here, but I can take the questions.
Okay, hi Deepali, how are you? Thank you so much for the thank you so much for the presentation. I think it was a very exhaustive one. You covered various use cases. There are a few questions that we have. We'll pick them one by one. One of them is by Dipesh, where he's asking, can we use this model to suggest how to redirect water flow and reduce floods at the same time increasing vegetation?
Um, yes, you can use that model, but I don't know what it's. Can he clearly explain what is that? What does that mean? So, can you read the question one more time, please?
Yes, sure. So I'll put it up here. So he is asking, can we use this model to suggest how to redirect water flow and reduce floods at the same time, increasing vegetation? Is it
Yeah.
through
Yes.
mapping?
Yes. Yeah. You can do that. Yes.
Hmm.
Mm-hmm.
Okay. Okay. There is one more question that we have received, which is from Bella. She's asking, you mentioned several models for forest flood mapping. Which one worked better and maybe why? If you could elaborate.
The model we used was the random forest flood for flood mapping, and also the tree boosting models like XGBoost. And XGBoost work better in this flood mapping. And we also tried actually the some CNN models as well. But in this flood mapping case, the XGBoost performed best.
Okay, okay. Thank you. I have one question that I was very curious to know. So you covered various use cases, and while they were very good, from an individual, like if an individual has to do them, the pre-processing seems to be a very difficult task to overcome. So, is there anything that anything that one can do if they have to do this on their own as a solo project? Is there any recommendation that you may have?
Yeah, sure. So pre-processing, you mean the satellite images? So that actually that's what I mentioned. This Google Earth Engine platform is very useful. So you can collect the data, you can pre-process it, you can have the filters. These, as I said, these satellite images sometimes may not be very clear because of the cloud cover and some atmospheric factors. So there is a facility, you can filter out the data, you can filter it according to your area of interest. So that can be done. Or otherwise, and this is actually the platform. Even though it's open source, but it can be used for the research purposes, and they have this commercially you can use it now. They just you started that thing. But there are some libraries like GeoPandas, Raster.io, which you can use for pre-processing the data.
Okay,
I
okay.
have a question too. So, What is, I mean, this is a very powerful use case, I feel like, for AI. So, in your experience, do you think that all these natural disaster management companies, especially like the government companies, where are they in adopting these methods so that they can flag all of these areas and all of these sensitive things even before they happen?
Yes, you can. Yes. So that's why we use, those time series. So we have the historical data, and from the historical, taking this historical data, and then you can use the time series, run the prediction, and then predict. So where those, the natural calamities, for example, the floods going to happen. So that's what we did. So that's, you have seen the maps that we created using the AHP and the machine learning models. So yes, that can be done.
Okay, I mean, my question was also more around like where is the adoption, right? Like where in the adoption curve, where are all of these government institutions who are responsible for some of these methods in your knowledge, right? Like are they adopting AI to do all of these predictions?
Yes, of course. Yes, yes,
Yeah.
they are. And I don't know. See, here in New Jersey, there is a Rutgers University, so they have this AI, separate AI department. In India also, a lot of work is been done using the this Earth observation data. So yes.
Wow, that's good to
Mhm.
know. That's good to know.
So typically these models, when they are implemented on the ground, are there any common challenges which are seen in terms of deployment? Because um, yeah, I mean, because we are talking about use cases across geographies and the data set could be specific to one. I mean,
Yeah, there are several challenges. As I said, these models, they use the data from the satellite mostly. So the satellite images might not be very clear and crispy. Sometimes, for example, in case of flash floods, so flash floods occurs very quickly. So in that period of time, the satellite may not be able to capture the images promptly. So in those cases like flash floods, you cannot really use the data. But there are private companies which provide the data, but again they are very expensive. So because if the drone data can be used in that cases, so drones are proving to be very useful in such cases.
okay, okay. Thanks, Dipali. I don't have any question from my end. So, Preet, do you have any question?
No, I think I'm good as well.
Yeah,
So we can
awesome.
wrap up. Yeah.
Yes, I think, yeah, so we are towards the end of the session in that case. So I would again thank you, Deepali, for being with us today and presenting all of your work around natural disaster management. It was on the website also, it's mentioned that you are one of the enthusiasts and about when it comes to climate change and mitigation, climate change issues and mitigation strategies, and rightly so. It was evident with your projects and all. So thank you so much for taking out the time to share it across with the community. And
Thank
thank you, Database, also like for being our old constant partner. So it was pleasure having this session with you again.
Thanks,
Thank
Mudit.
you so much, Modi and Suprit, and thank you all for listening to today's presentation.
Of
Thank
course,
you.
of course. And I think we can share the presentation, right, to the
Yeah,
audience.
you can. Yes, and there are I have mentioned the article link. So if you want to know more about it, you can read the articles. And if you have like any further questions, you can contact me there. I
Awesome.
left the email there. Yeah.
Thank you so much. Thank
Okay.
you.
Thank you.
Thank you, everyone.
Thank you all. Thank you.
Bye.
Bye bye.